This section is about law of cosines. So what happened in the previous section, we learned about law of sines. Law of sines to help us find missing sides and angles. And we showed you an application to that in real life situations. Now, one thing we would like you to know that in law of sines, when we use law of sines, it doesn't work out the whole time. So law of sines doesn't work in some cases. What are these cases? If they give me side angle side or side side side. In this case, if you try to set up the law of sines, it's not going to work out. So that's why we need another tool, and this tool is called the law of cosines. Law of cosines. What is the law of cosines? The law of cosines, let me prove it. It's fun to prove this. Say we have triangle ABC. We drop a height. Call this H. So that we know that the side facing C is C, facing AA, facing BB. Let's call this D, and this is X. So this would be C minus X. So the first thing, in the right triangle, in this triangle here, we have by the Pythagorean theorem a squared equals c minus x squared plus h squared. And when I expand this out, you square the first one minus 2cx plus x squared and keep h squared the same. Now, another thing we can do in the right triangle, in the left triangle, this triangle here in red, this triangle, we have that by the Pythagorean theorem, we have b squared equals x squared plus h squared. So what I'm going to do, I'm going to replace this with b squared. So then a squared equals c squared minus 2cx plus b squared. Let me rearrange this. Write b squared first, then c squared minus 2cx. One further step to do is to solve for x. I want to get x. If I take in triangle, the red triangle, so in triangle ADC, cosine A is the adjacent over the hypotenuse. So then x equals b cosine A. We are going to replace this here. So I get a squared is b squared plus c squared minus 2 bc cosine A. So we can summarize it here. We can summarize the law of cosines here. Notice what we get. A squared equals b squared plus c squared minus 2b times c cosine A. If I start with b squared, is that possible? Yes. If you have to drop a height on a different side, you get a squared plus c squared, like the Pythagorean theorem, minus 2ac cosine b. Or if you want to start with c squared, that's a squared plus b squared minus 2ab cosine c. So notice a is facing a, b is facing b, c is c. So that always matches this way. And can we apply this to an example to see how this works? Solve triangle ABC if angle A is 60 degrees, the measure of that angle, B is 25, and C is 32. First thing, they give me two sides and one angle. So if you randomly want to draw a triangle ABC, B is here 25, C is 32, and angle is 60. So what... actually, no, they give me C, the C down there. See, it's a side angle side case. So, law of cosines. So, to find the law of cosines, or to use the law of cosines, we first start with the side that facing the given angle, which is this side, that's A. That's the given angle. So, how do I find A? A squared is B squared plus C squared minus 2BC cosine angle A. A squared equals B is 25, C is 32, 2 times 25 times 32 cosine angle A, which is 60. So then A squared equals 849. So A equals, if you put that in the calculator, it gives us about 29 inches. Or meters, or whatever the unit is. So let's say 29. So I found the side. Now I can use law of cosines to find the next angle and the other angle. But always keep in mind, when you use a law of cosines in one angle, as you notice, there's more work in law of cosines than law of sines. Always when you use the law of cosines in one problem, if you continue to try to solve the problem, use law of sines. Use law of sines. So in this case, I want to find one of the angles. This is beta, this is gamma. Let's say I want to find beta. So you're going to say sine beta over 25 equals sine 60 over A, which I just found, 29. So then 29 cross multiply, sine beta is 25 sine 60. So sine beta is 25 sine 60 divided by 29. And that gives us beta equals sine inverse of 25 sine 60 divided by 29. If you put that in the calculator, beta is about 48 degrees. I found beta. So law of cosines, law of sines, and now there's one thing left to find, gamma. The easiest way, gamma is 180 minus alpha plus beta. Alpha was given 60 degrees. We found beta 48 degrees. And if we do the work, gamma would be 72 degrees. So can I use the law of cosines to find what I found here for beta? Yes, you can, but it's going to be a lot of work to do that. And why is that? So before I do this, as a note, usually this is how it works. Law of cosines if needed, then law of sines. I'm just trying to make it easy for you. And then the A plus B plus C equals 180 degrees. The steps are important. This is important. Another note, if you happen that you want to find beta using law of cosines, that's okay. You start with B squared because you want beta. A squared plus C squared minus 2A times C cosine beta because you need beta. Okay, so now I want to solve for beta. So what you can do, you can substitute. B was 25, A was 29, C was 32, minus 2 times 29 times 32 cosine beta. 625, 1865. If you do this together, minus 1856 cosine beta. Then subtract this from both sides, you get a negative 1240 equals negative 1856 cosine beta. We need to find cosine beta. 0.6681. What is beta? Cosine inverse of 0.6681. So beta is about 48 degrees. That gives me the same answer. But notice which one has more work? Well, the law of cosines. In general, if I want to find, let's say, if I start with law of cosines again, a squared plus b squared minus 2bc cosine angle A. Okay, look what I'm gonna do. I'm going to kind of add this to both sides and subtract a squared to both sides. So that thing comes to this side. Keep b squared plus c squared the same, subtract a squared. Then divide everything by 2bc. 2bc. So that gives me cosine A equals b squared plus c squared minus a squared over 2bc. That's cosine A. If I want to find cosine B, this is how you find it. Watch, since it starts with A, you do B and C. So starts with B, you do A and C, A squared, C squared. And always 2 in the denominator. If this is A and C, AC goes here. And always minus the one that facing that B, which is B squared. That's cosine B. Now you can kind of pause the video and try to find one for cosine C. If you do so, that will give us A squared plus B squared over 2AB and minus C squared. So that was the case when it's given as side angle side. What about SSS case? So SSS case. When they give us 3 sides. Let's say solve, they give us triangle, solve triangle ABC if A is 34, B is 20, C is 18. So they give me 3 sides. So that's a SSS case. In this case, what we need to do is, you can draw the triangle if you like. This is A, B, C, and A is 34, B is 20, this is 18. So what we need to find is, we need to find the missing angles. You can start it with any angle you like. Let's say you want to start with angle A. So you say cosine A, the one we just showed you or proved to you, it's B squared plus C squared minus, and here you have 2BC minus A squared. So cosine A equals, notice B is given 20 square, C is 18 square, 34 square. 2 times 20 times 18. And if you put that in the calculator, making sure when you put that in the calculator, put a parentheses around this if you want to put all this in one step. Otherwise the calculator would not understand it this way. So then when we divide this together, that gives us negative 0.6000. So if you get a negative number, it's fine. That doesn't mean something wrong here. So then A would be cosine inverse of that number. Okay? And if you put that in, the calculator will give us 127 degrees. This is to the nearest degree. So I rounded to the nearest degree. I found angle A, which is an obtuse angle. That's why, because the cosine was negative. It's an obtuse angle. So what did I use here? I used law of cosine to solve for A. So let me go back to the figure. This is 127. I need to find the rest of the angles. Again, as I said, you can use law of sines now. Sine A, which is 127, over A. What was A? A was 34 equals sine B. Let's say I want to find angle B, over B was 20. Okay, so now we can multiply 34 sine B equals 20 sine 127. Then divide both sides by 34, so 20 sine 127 divided by 34. So B is sine inverse of 20 sine 127 over 34. And what does that give us? B, angle B is 28 degrees. That's what B is. Now, how do I find C? The easiest way, C is 180 minus A plus B. And that would be 180 minus 127 plus 28. Let's see what that gives us. That gives us 25 degrees. So I found all the missing sides and angles with the help of law of cosines, then law of sines, and then the 180 equals A plus B plus C. Now let's look at an example, like an application. I'm gonna do go over number 50 on page 539, and I'm gonna say exactly what the question is saying, what it's stating. So this is about finding the length of a wire. They call it a guy wire. So we have a radio tower. So let's say this is the ground level. Okay, so and We have a radio tower that is 500 feet high, is located on the side of a hill with an inclination to the horizontal, this is the horizontal line, of 5 degrees. So this is the 5 degrees inclination. There is a tower on the top of this. This tower is 500 feet height, and what we need here to do is, they said, how long should the two wires be if they are connect to the top of the tower? So you get the wires. This is one of the wires and that's the other wire. We need to find the length of each wire and be secured at 2 points 100 feet directly above and directly below. So there's 100 feet here, 100 feet below, and 100 feet above. So let's call this X and this Y. So we are asked to find X and Y. And remember it was 500 feet tower. So let's see, how do we work with this one? That was the tower here. First, I'm gonna find X. How do you find X? So what we can do first is we can draw a line down this, like continue the line, perpendicular line. This is 90. This is not 50, that's 5. So this is only 5 degrees, as the question stated. So in this small triangle down here, I can find this angle, which is 90 minus 5, 85 degrees. And the 85 is the same as this one, 85. Vertically opposite angles are equal. Why did I find that angle? Because I want to find that X. So in that triangle here now, I can use, they give me, notice what they give me, side, angle, side. I can use law of cosines. By law of cosines, I can find X by doing X squared equals 500 square plus 100 square minus 2 times 500 times 100 cosine 85 degrees. See, that will get me what I need for X squared. So if you do these two together, that's 260,000 minus 100,000 cosine 85 degrees. Then X would be the square root of all of this. You can either calculate it first and then put it under the square root at the end, or you can do it like so. And then when I calculate this, it gives me about 501.28 feet. So that's the length of one of the wires, X. Now I need to find the length of the other wire. So the other wire, I'm going to take this triangle, this, and this. So let me redraw the triangle down here. So we have the triangle like this. This is 500 feet. I'm looking for Y. This is 100 feet. If I want to find this, I need the angle included there. So this angle here was given as 85. So I can find the angle on the other end, which is 180 minus that. So this angle here is 180 minus 85, which is 95 degrees. So now, law of cosines again. Law of cosines again. Y squared equals 100 square plus 500 square minus 2 times 100 times 500 cosine 95. And then again, we can do calculation. 260,000 minus 100,000 cosine 95 degrees. And if you do square root of this, I found Y to be 518.38 feet. Notice they're not the same. Kind of close, but not the same. Okay, that's a important one. Now it depends, it depends on the diagram. Depends, some diagrams they give you different numbers or different givens. Sometimes they give you angles, sometimes they give you sides, different sides, different angles. But at the end you want to decide which law you want to use. Law of sines, law of cosines. Again, law of sines is always easier to use than law of cosines. Less work and less mistakes. Sometimes people make mistakes with the law of cosines with the order of operations. So I'm gonna write that note down. Let me write an example. Let's say someone is finding a square is, I'm gonna throw random numbers. 2 square plus 3 square minus 2 times 3 cosine, let's say alpha. So this is a common mistake. This is what students do. They do 4 plus 9 minus 6 cosine alpha. And then they go ahead and they add 13 minus 6 cosine alpha. Then a squared, 13 minus 6, they put 7 cosine alpha. This step from here to here, it's a wrong step. Even if alpha is given. So let's say alpha is given as 15 degrees, let's say. It doesn't matter if it's given or not. So if you put 15 here and 15 there, that's still wrong because we have what we call order of operations. You must do this by itself first, this one first, then 13 minus whatever you get, and then do square root. So then a would be the square root of 13 minus 6 cosine 15. That's very important to know.